Good morning, everyone. I hope you are able to hear me.
Yes, Karthik.
Yeah, thank you. Okay, I think you are able to see my screen as well. Yeah, thank you. So let's quickly look at what we have learned in the last class. So yesterday there was no class, but we did discuss about the lock mechanism on Saturday. Now, can someone tell me what are the drawbacks of synchronization or synchronized keyword?
Acquiring the lock in one method and releasing the lock in another method is the one disadvantage.
Okay, and any other? So when you are using a synchronized keyword, so if I assume that if multiple threads are working on same object and accessing different synchronized methods, can I say in this scenario, only one thread will be given the access at any point of time and remaining all threads will be on waiting mode?
Yes.
Okay, whenever the threads are waiting mode, when the current thread completes the execution, so other thread will be given the access. Do you know which thread will be given the access? That means, is it anything based on the waiting time? That means which thread is waiting for longer time should given the access first, ideally.
Yes. Yes.
So, but can we control that in the synchronized keyword?
No.
Yeah, that is another drawback.
Yes.
Yeah, whenever we are using a lock, what is a lock in Java?
Acquiring the object means a lock on the method.
Okay, so lock is an interface which is which will work similar to the synchronized keyword, but it provides some flexibility. So now let us look at that flexibility. So what are the classes which are implementing lock interface? Reentrant lock. There is a class called reentrant lock, which we have seen in the previous class, right? So in the reentrant lock, so if I have to do the locking mechanism using a synchronized keyword, I can write a synchronized keyword to a method or synchronized keyword to a synchronized block as well, correct? Now, but if whenever I'm using lock, how can I do the lock? So lock is an interface. So reentrant lock is one class which is implementing this interface. So first I need to create an object of that class, right? And then object, by calling the lock method, we can acquire the lock. By calling the unlock method, we can release the lock, correct? So in the example that we have seen, see, look at here, from the run method, I'm calling the display and I'm acquiring the lock in a display method and releasing the lock in display one method. That means we cannot do this one in the synchronized keyword because synchronized block should be written within the method. You cannot write a synchronized block starting in the display method and ending in display one method, right? Now, in order to use a lock interface, we need to have one implementation of a lock interface. The class is reentrant lock. And there is another class called reentrant read write lock. I'll come to that later. Now we also have seen what is the difference between a fair lock and unfair lock.
Yes.
What is that? What is fair lock? What is unfair lock?
So fair lock means we are giving the priority to the most long time waiting thread. Say if it is unfair lock means we are giving means so randomly we are giving the access to that threads.
Yeah. So unfair. So by using the synchronized keyword, can I say that we are getting unfair lock only?
Yes.
It does not matter about how much time it is taking. Correct.
Yes.
So using the fair lock mechanism, how can we achieve a fair lock? By passing the true to the constructor of a reentrant lock class, we can achieve a fair lock. In the fair lock, the thread which is waiting for longer time will be given the access first on the same object. If it's a different object, we don't care. So because lock mechanism comes into the same object, like multiple threads are trying to access different methods on the same object, right? Now, so unfair lock means it depends on, like the problem with unfair lock is there may be a situation that the thread which is waiting can be waiting for longer time. Okay, it might never get a come back to the execution as well, right? Now, yeah, is this the one? This is what we have looked at in the previous class, correct? Now let us look at read-write lock. Now before trying to understand what is read-write lock, now let us go to the example that we have drawn whenever we are studying the object lock, class lock. Can I say that we have created one HDFC Bank or SBI Bank example? Now let us go back to that example. Now what are in the, whenever we are studying that, can I say in the bank example we have created, what are the methods we have written in the bank example class?
Deposit with
Deposit and withdraw.
Deposit and withdraw. So, and can I say that these methods, I have made methods as a synchronization, correct?
Yes.
Okay. Now, let us, so whenever you have a bank, can you do the balance inquiry from UPI?
Yes.
Okay. Can you do the balance inquiry from net banking?
Yes.
Okay. Now, see, for example, now let me write balance inquiry from UPI. Balance inquiry from net banking. Okay. Now, if I make these as methods also synchronized, now all the, see, I am creating T1, T2, T3. All these are working on Karthik account. Okay. Now, if T1 is trying to access balance inquiry from UPI, can T2 should be able to access balance inquiry from net banking on the same Karthik account?
No.
Okay, because you are making these methods as synchronized, correct?
Synchronized.
But if you think about providing this functionality for, especially for these two methods, balance inquiry from mobile app, that also I will write. Balance inquiry from mobile app. Okay. So assume that this is also synchronized. So if you look at these three methods, so what is the work of these three methods? It is just getting a balance from your account and displaying, correct? Now, so if you make these methods also synchronized, what happens? In only one thread can execute. But can I say, I'll take mobile app, net banking, UPI. If I give the access, all can I say that all these are the read threads?
Yes.
They are reading the data from the like banking application. Now, can I say deposit and withdraw are nothing but a write threads?
Yes.
Okay. Now, if you are using the regular mechanism of synchronization, whether it doesn't matter whether it's a read thread or write thread. When I say read thread, that means it is, can I say that these are performing a reading operation, like reading the data from the database and giving you the data. Now, write operation means deposit and withdraw. Write means, can I say it will modify your balance? So that's what the write operation means. Now, whenever we are using a synchronized keyword, it doesn't matter whether it's a read operation and with the write operation, as long as methods are synchronized, only one thread can execute one method on a Karthik account. Now, for example, now let's give some more flexibility, right? So if I provide one way that any thread can execute this read thread. So whenever a thread is one thread, for example, T1 thread is trying to get the balance from UPI. At the same time, I will provide the flexibility to T2 thread, execute mobile app, balance inquiry from mobile app, T3 thread, balance inquiry from net banking on the same account, on the same Karthik account. But I want to keep deposit thread and withdraw thread. So what I'm trying to say is, when read threads are performing, all the write threads should go into the wait mode. When one write thread is performing, all the read threads should go into the wait mode. Now, in this way, I'm providing you some flexibility. Let us see. Now, earlier, whenever T1 is working on UPI, it will acquire the lock. Can T2 work on another thread method on the same object? No, correct? Because it is not a matter of whether it's a read thread, write thread. Only one thread can execute one synchronized method on one object. Okay. Now, but what I'm providing you the flexibility, since these are the read threads, whether you read anytime, the output may not modify until the write operation starts working. Now, what I'm doing is in the read write lock, what happens is multiple threads which are trying to read can work at a time. While this read thread is working, all the write threads will go into the wait mode. So, for example, now let us assume that T1 thread is working on UPI. Can I say, is it a read operation?
Yes.
Yeah, I repeat, T1 thread is working on balance inquiry from mobile app. Okay, it's a read operation. Now, whenever this lock is acquired, it's a read lock. Then what are the write threads? Write operation, a thread which is doing the deposit, a thread which is doing the withdraw on the same account will go on wait. All the write operations will go on wait. When all the write operations are going on wait, can I say remaining threads also can start executing, correct? Because when your write operation is on hold, whether you can you give the access to all the read threads, correct? Because when write and read are happening simultaneously, then you do not have a balance updated properly. But when the read thread started executing, automatically write threads are going into the wait mode. Then can I say, instead of waiting, like when T1 is executing a balance inquiry from UPI, earlier with the synchronized keyword, T2 thread balance inquiry from mobile app should wait. But with the new implementation of read lock and write lock, so T1 is executing balance inquiry from UPI. This will acquire the read lock. Immediately, all the write operation threads will go on to a wait mode. Can I say that immediately can I give the access to the T2 thread, which is executing balance inquiry from mobile app at the same time? So
Yes.
it will save some time, correct? Because
Yes.
these are the read operations. If you read, see, as long as the write operation is on hold, there is no harm to do the read operation multiple times using multiple threads, correct? On the same object. Yes or no?
Yes.
Yeah, I repeat the same thing. So if I don't perform deposit and withdraw, can multiple threads work on these synchronized methods at a time? Not with a synchronized keyword, but in your whenever you are developing or with your common sense, can I say that if I don't want to perform deposit, I don't want to perform withdraw. Is it good if I don't perform, then by using a synchronized keyword, unnecessarily I'm wasting the time, correct? Because it is waiting for one lock to complete, right?
Yes, sir.
Yeah. But if my example says that whenever I don't do the write operation, which is nothing but deposit and withdraw, is it good to provide the access for all the readable threads? Like T1 can execute at a time, T2 can execute at a time, T3 can execute at a time, these three methods on the same account? Then can I say that it is fast and no harm to my application?
Yes.
So that is what happens in the read log. So in the reentrant read write log, there is a class. In that class, we have a read log, write log. Okay. Now the question comes, sir, how can we define read log or how can we define write log? Can I say in this example, which are performing the write operation? Which methods?
Deposit and withdraw.
So can I say in this method, I will write the code?
Yes.
So how to achieve the lock using a lock interface?
Lock method.
So on the reentrant lock object, you have to call the lock method.
Lock method.
How to release lock? Unlock, correct? Now here also lock dot unlock. Okay. But whenever you're using a lock method or unlock method, does it telling you that is it a read lock or write lock?
No.
No. It is just telling you that it's a lock, right? But
Yes.
now, since we have learned the read lock and write lock, instead of implementing the normal reentrant lock class, we will create an object to the reentrant read write lock. There is a class. In that, there is a method called read lock. There is a method called write lock. So that means whichever the method, so whenever I'm writing my implementation, I know whether it's a write operation or read operation. Accordingly, I have to write the code. In the deposit method, I will write a write lock. In the withdraw method, I will write a write lock. Can I say in all these three methods, I have to create a read lock and then lock it? Yes?
Yes.
So now let us see this example. At least hope you guys understood the concept. The difference between a synchronized keyword or lock mechanism for a read-write lock is when one thread is reading, all the read threads can execute at a time, while write threads will go on to a wait mode. I repeat, all the reading threads can execute at a time, multiple threads on a same object, while write threads can execute, has to go on wait. Now let us create. Okay. Now let us, I have already created. Let me remove this code. I'll keep it in Notepad in case if we need it. Okay. Now I just have one class called HDFC Bank. Okay. Now as I told you that we have a lock interface, correct? So lock interface has a lock method. Now let me show you there is a, so if you look at here, there is one more interface called read write lock. In this one, do you see one method called read lock? And another method called write lock?
Yes.
Now, what these are returning?
Lock interface.
Lock interface. Now, how to, after calling this method, it is returning a lock interface. Then, so that means, can I acquire the lock directly? No, it is returning a lock object. On top of the lock object, I need to call the lock method, correct? To acquire the lock. Am I right?
Yes.
Yeah. Now let us do. Now let us create. So now which class is implementing the read write lock? Reentrant read write lock is a class which is implementing a read write lock interface. Now, if I want to use this, then I have to go for this one. Now what I will do. So reentrant lock, look, new reentrant lock, done. Now, what are the methods we want to create? Deposit, correct? Now, since I'm using a locking mechanism, do I need to write a synchronized keyword?
No.
No. Yeah, good. So can I say void deposit? Can I say deposit means it should take double balance deposit amount. Now let me create a double amount equal to 0. So what is the operation I need to perform? Amount equal to amount plus deposit amount, correct? Now, is it a write operation or read operation? You guys tell me.
Write operation.
Okay. Now, in order to write operation, so I need to acquire it. If it is a write block, I need to acquire the write lock. Now, since in this class, so what is the method that is acquiring? Since it is implementing this read write lock interface, can I say it should have overridden the write lock method? Look at here. It has overridden the write lock method. Because it is there in the interface. If it is not overridden, the class will become abstract. Okay. So let me go to the class and see directly. L dot write. Say L dot write lock. Are you able to see? Yes.
Yes.
So they have implemented somewhere the mechanism will be somewhere in this class. Okay. Now look at here somewhere. So now what this write lock method is returning? Lock interface, correct? Now can I say lock L1 equal to, correct? Now, so, but in Java, if you are using a lock interface, how to acquire a lock? By calling the lock method, correct? L1 dot lock. So see here, whenever you're using a lock mechanism or synchronized block, whichever the code you want to keep, that you want to keep it in a synchronized block. Now, similarly, whenever using a lock mechanism, whichever the code I want to make it as a lock or thread safe, before that line, I need to start this one line, correct? Now, can I club these two lines? Now, let us see. L dot write lock dot lock. So can I say line number 13 is same as line number 11 and 12?
Yes, yes.
Yeah. So I'm getting the object and then calling the mechanism, or I can do like this. Okay. Now let me comment these two lines and let enable this line. I see if I have written 13, you might get confused. Now once I acquire the lock, when should I release? After the completion of this line, correct?
Yes.
Now write lock dot unlock. Okay, done. Can I say this is my implementation for a deposit? Now let us withdraw. Can I say withdraw also write operation?
Yes.
Okay. Now I'll just, so can I say I have to acquire the lock also, write lock, done. Now let us write one more. Void balance inquiry from UPI. Okay. So balance inquiry means you don't need to give anything. Like assume that you are inserting the card already. Now balance inquiry. So whenever you are doing a balance inquiry, is it a write lock or read lock?
Read lock.
Read lock. So what this method should return? Or else let me do system.out.println. Sys out balance is. Okay, let me keep it as amount. Okay. Now since it is a read operation, I have to acquire the read lock. L dot read lock dot lock. Now I have to release the lock, correct? Okay, done. Now can I say same kind of a method? Even if I do balance inquiry from net banking, can I do the same thing? It has
Yes.
to also acquire the read lock and then it has to return the amount. Yeah, if I have to do balance inquiry from mobile app. I hope you guys understand everyone what is the code I have written so far. Anyone, any questions so far on the code?
No, sir.
Karthik, can you just show the read lock again?
Okay. Yeah. So I want to do balance inquiry from UPI, balance inquiry from net banking, balance inquiry from mobile app. So can I say all these are read operations only? Balance inquiry means I just wanted to see what is the balance. So there I don't need to update anything. I just wanted to see. So since it is a read operation, so I want to acquire the read lock. How can I get a read lock? So we have a class called reentrant read write lock. In this one, there is a method called read lock. So I'm getting a read lock. And then it's a read lock method also will give you lock object. How can I acquire a lock on top of that? Whenever I'm using a lock interface, by calling the lock method. Understood? The one who asked.
Yes, Karthik. I'm audible.
Yeah. Yeah, thank you. Now let us, so now can I say that I have implemented my bank functionality? Now what I should do, guys? Can you guys tell me? I have implemented my bank functionality. Now what else I need to do now? What else I need to do? So what is the example is talking about? See, can I say deposit, withdraw, balance inquiry from mobile app, UPI, net banking? Can I say I have created all the methods in the bank? Yes. Now what else I need to create? You tell me.
Threads.
Yeah, correct. Now threads. In order to create a threads, earlier what we have done? We created a class for each thread. ATM thread, one class. HDFC UPI thread, one class. Net banking thread, one class. And implementing runnable interface and taking the Karthik account as a parameter. But in the last class, we also get to know how to create a thread using what you call Java 8, correct? Now, can I do that? It would be easy, right?
Yes.
Now let us create thread t equal to new thread. Okay. Now, so if I am using this one, can I write anonymous in a class like new runnable? Yes. Instead of that, so runnable is a functional interface. Can I write a lambda expression? Yes. Now, what is that lambda expression? It so the run method does not take any argument. So your method also should not take any argument. Done. Now, and then run method has to call some other method, correct? Yes or no? So
Yes.
so whenever from the run method, you will be calling any of these methods, deposit, withdraw, or any other. Now, so deposit, withdraw are calling on which object? HDFC account object, right? Now I need to create a HDFC bank. HDFC bank. Let me keep K. So I'm putting the shortcut, like instead of writing Karthik account, I'm putting K. Okay, now can I say that K is my object, right? On top of a K, you want to call the deposit using one thread. Now can I say that K dot deposit?
Yes.
And then I want to deposit 1000. Now, can I say this is one thread now?
Yes.
So now if I have to implement this instead of a lambda, can I say I will create one class, implement runnable interface or extend run thread class, and then override the run method. And in the run method, you need to call this method. Now, can I say that I have simplified that entire logic of code like this? Now, so here, how many threads I said? T1, T2, T3, multiple threads. Now, if I want to create one more thread, can I say T2 or T1? Let me create T1, T2, and then in the T2, I want to, instead of deposit, I want to do withdraw. Correct? Done. Now, we have another methods also. Let us create some other threads. Now, T3, T4, T5. Using T3, I want to call balance inquiry. Balance inquiry from net banking. Okay. Now, let me call balance inquiry from UPI. Now, let me call balance inquiry from mobile. Okay. Now, can I say that I have created 5 threads? And each thread, say, can I say in this one, which threads are performing a read operation?
T3, T4, T5.
Okay. Now, can I say now read operation T3, T4, T5. Write operation
T1, T2.
T1, T2. Now, when can I say that these 3 threads can execute parallelly? And when any of these thread is executing, this thread should go to wait mode. Correct? When read operation is executing, write operation has to go on wait mode. When it has to go on wait mode, then we can execute parallelly. Now, that is what the read. Now, can I say that I have to call the start method?
Yes.
Now, instead of calling T1.start, can I say this is a T1 is an object? Can I create start method here?
Yes.
Or else let us do separately instead of making. T2, T3, T4, T5. Okay. Now, guys, any questions, anyone as of now in the code?
Sir, one doubt, like, we are doing write lock and read lock.
Yes.
So both are locks only anyway. What is the difference for read and write?
Yes. Read, see, it's a lock only, but I'm acquiring the read like a read lock and write lock. See, whenever you are performing read operation, can I say that, see, I'm differentiating between earlier, whether it's a read operation or write operation, it doesn't matter, correct? When
Yes.
one thread is executing, if, for example, if one T1 thread is executing balance inquiry method, okay, on Karthik account, can I say T2 thread balance inquiry from UPI, it has to wait, correct?
Yes.
So in the earlier synchronized mechanism or lock mechanism, you do not have any difference between read method or write method, correct? Now, but the
Yes.
problem with this is, now if you take a scenario, T3, T4, T5, all these threads are taking, like doing the read operation only, correct? They want to read the data from the, like balance amount from your bank, okay, on Karthik account. Now, can I say if you are trying to do this and I don't want to do the write operation, that means I have an account in the bank, I will never deposit in that. But if I try to perform the operations of reading, like getting the balance inquiry through different modes like Paytm, UPI, net banking, at that time, if you are using a earlier mechanism, can I say that though you are not doing anything right operation, do you need a synchronization?
Not required.
So that means I am not saying that in this read lock, the synchronization will not happen. But see, can I say that when, as long as there is no write operation, can I say multiple threads, I should provide a access to the multiple threads to read?
Yes.
Yeah. So that is the advantage we are getting in the read lock and write lock. In the read lock, what happens? Whenever multiple threads are having a read lock, can execute at a time. When the read lock is executing, write lock will go into any thread that is executing the write lock on the same account will go on to a wait mode. When writing thread is working, all the read threads will go on to a wait mode. That is the advantage, correct? So here you are doing the lock mechanism, but can I say that based on a write operation and read operation, you are differentiating so that some of the threads can run parallelly and then your work will be fast?
Yes, sir.
Yeah.
But if my doubt is like if you are doing read operations, my understanding is like if you are doing read operation, the write operation should be wait. If you are
Yes.
doing write operation, read operations will be wait.
Wait. Yes. Yes. Correct.
Anyway, it is wait.
No,
only.
that is what I am telling. So here, how many threads are doing a read operation?
Read is
3 threads, correct? If you are
yes.
using a normal threads synchronize or lock mechanism, only though you are trying to read 3 threads, only 1 thread will execute the read method, correct? But
Yes.
now I will show you when write, there is a lock, wait method lock on the write operation, 3 threads can continue parallelly execute the read. Hope you understand. Now let me show you, and so that you can understand. Okay.
Okay.
So you're not thinking about how many number of threads are executing. Earlier, whenever you are without this read like on write lock, there is a lock. Whenever there is a lock, only 1 thread can execute 1 method, correct?
Yes.
Now, I will show you on the same object, 3 threads can execute parallelly. Can I say I'm improving the efficiency?
Yes.
Yeah, that is the advantage. Now let us keep the debug. Once you debug it, you will get to know. I'm keeping the debugger in the all the methods.
Yes, from withdraw, you can add that minus sign.
Yeah, so this is a business logic. I don't care about it, but okay, fine. Now let me change the amount as well then. Okay. Now let us start the debug as Java application. Now whenever I am debugging, currently how many threads? Only 1. I'm creating a thread objects, correct? Now, so can you see, do you guys agree T3, T4, T5 are reading threads?
Yes, Karthik.
So T1 and T2 writing threads.
Right.
Now, let us do, so now let me start T1 dot start, T2 dot start, T3 dot start, T4 dot start, T5 dot start. Whenever I say start, which method gets invoked?
Run method.
Okay, but do you have you guys written run method here?
No.
But how it will go? Can I say that this is your run method
The
implementation
expression.
internally, correct?
Yes.
Now, so look at here, it has come. So whatever you are writing, can I say this after the arrow mark, this is a run method implementation?
Yes.
Okay, now let's see. See here, currently T0 thread is in write lock. Does it acquire the lock? No. After completion of this line, only it will come, correct? Now let us go to the next. See, withdraw method. See, T1 is executing withdraw. And T2 is executing balance inquiry from net banking. T3 executing balance inquiry from UPI. T4 is executing balance inquiry from mobile app. So why did I come to this line? Because I have not kept a debugger here. Directly it has come. Now let us execute. So what are the reading threads now? So in Ganesh, just now you just answer my question.
Yes.
So T4 thread is executing one method. Now, can I say if I do F6 in the T4 thread, can I say it will acquire lock?
Yes.
Okay. Now when there is now I'm talking about a normal lock and synchronous method. Now T4 thread is executing balance inquiry from net banking mobile app and it has acquired the lock. Can any other thread execute any other method on the same object?
Those are in other approaches.
No. But in this scenario, what is a T3 thread? Now I will show you. T3 thread can execute other method. Can I say that is nothing but a parallel execution is happening? I'm acquiring the lock and at the same time, other thread is also executing, correct?
Yes.
So that is an advantage. Now let me show you guys. Now, what is a T4 thread? Can I say it's a read operation, right? Now,
Yes.
now I am telling that. So now if whenever I am at this line, if I click F6, can I say that I will acquire the lock? But what lock I will acquire? I will acquire the read lock, correct? Now let me do F6. See, can I say I have acquired the read lock? Yes or no? Now
Yes,
T4
yes.
thread has acquired the read lock. Now, when the read lock is acquired, then write lock has to go into the wait mode. Which threads are doing the write lock? Thread 0, correct? Now, currently it is suspended. Now, if I click on, from here, the debugger will go and this will go into a stepping mode, correct? Now, let us see. See, can I say it is stepping mode? Can I say it is waiting? Thread
Yes.
0? Now, what is the other thread which is writing operation? Thread 1. Now, let us do F8. See, it is also went into the stepping mode, correct? Now, so that means whenever I am doing the read operation, read lock is acquired. So whenever the read lock is acquired, all the threads on the same object which are trying to do the write operation, can I say those will go on to a wait mode? Yes. Now,
Yes.
can I say T3 thread? What is the lock it has? T3, read lock. So since I have a read lock and I have provided the stopping or waiting for write, can I say multiple reads can execute at a time?
Yes.
So that is the advantage over a normal lock mechanism, correct? Now look at here. If I click F6, can I say it is executing? Sorry, I think what happened? Maybe different object. Just give me a minute. I'm just checking. Just a minute, guys. There is some issue in the code. Okay, let me try. Okay. Okay, let me stop this. Let me use this. So there is some issue. Let me replace this code. This is also a same. I might have done some mistake somewhere. This is also same code. Look at here. Deposit method. I have a balance inquiry from net banking, balance inquiry from UPI. So what I'm doing, log dot write log dot log read log. And I'm doing the profile. So T1, I have created an account. I have created this. I've created this. I have created this. Now let me start this. Debug as Java application. Sorry, I forgot to keep the debuggers. So hence it stopped executing. T2 dot start. T3 dot start. T4 dot start. Yeah. So first thread. So second thread, third thread, fourth thread. Okay. Now when I say first thread, what it is doing? Now in this one, let us modify the thread numbers. T1 is balance inquiry from net banking, balance inquiry from UPI. T1 and T2 are read. Okay. Now T3 is also a read. Instead of mobile, I kept a profile. Now T4 is a deposit. Okay. Now there is no T2. Now let us do T1 is executing. Okay, T1. Now let us create start method. So here now let us go into the start method. Yeah. So look at here. Thread 1 is executing a read operation. Now let us do. See, this is also executing. Thread 0 is, see, look at here. Thread 1 is what method the current control is? Balancing query from UPI, correct? Now,
Yes.
can I say it is a read lock? Yes. Now, at the same time, are you able to execute another thread on the same object?
Yes.
Sorry, another method on the same object? Yes. Because these are read locks. Okay. That means whichever the threads that are having a read lock can execute parallelly. Look at here. See, it is executing. But at the same time, while read threads are executing, now let me try to do the write operation. When I perform the write operation, look at here. Does it executing? Can I say it is going on wait mode?
Yes.
Right. So now net. So whenever you are performing a read operation, can I say my write method is going on wait mode? Now let us complete this one. Let us complete all these threads. Read threads, all the read threads are completed. Now can I say first, if I complete this, can I say one read thread is completed?
Yes.
Now, but still the deposit method is come back to the execution or not? No, because so when the write thread will come back to the execution after completion of all read threads, correct? Now let us look at, because one has, see, other through threads are having the read lock. All the read locks has to be released. Now, when I do like F6, now can I say from line number 25, see, it has gone. Now let me go to the balance inquiry. Now let me do this. Now, whenever I do line F6 now, can I say that all the read locks are removed? Yes. Now look at here, deposit started executing, correct?
Yes.
Yeah. Any questions?
Previously also it will work, sir, but I think
Yes.
you have done first one suspend,
Yes,
then again
yes.
right you have done. That's why
Yes.
the other read has become the stepping.
Yes. So while I am debugging, I realized that whatever you're saying, but again, like instead of doing F12 and redo the coding, same code is there, so I have executed. Yes, as you mentioned, that's right. I have realized while explaining. Yeah, Nagalakshmi, I will explain this what is a extends and runnable little later. Okay. Now, do you guys understand what is a read lock and what is write lock? Okay. So now let us now what I did first. I have given the priority to read. Now write went into a wait mode. Now let me give the priority to the write now, and then see whether all the read threads should go into the wait mode. Let us see that. So now can I say my T4 is nothing but a write thread, correct? Now what I will do, I will acquire the write lock. Now whenever I see, can I say what happened? Now am I working? So that means currently one T3 thread is doing the deposit write operation on a Karthik account, and it has acquired a write lock. Earlier you were saying only lock, but now what I'm saying the write lock or read lock. Now once the any one thread is doing the write lock, can I say all the read threads has to be suspended, right?
Yes.
Because whenever you're writing and you're performing the reading operation, can I say the output may not be accurate, correct? Now let us see, look at here, profile data. Now let's see here. If I do F6, it will go into a stepping mode. See, it has gone. Similarly, if I do F12, it will go into a stepping mode, gone. Right? Now, it is also F12. Sorry. Yeah. So that means when any one thread is doing the writing, all other reading threads will go on a wait mode, correct? Hope you understand.
Yes,
Ganesh?
Karthik.
Yes, sir.
Yeah. Yes, Kishore, whenever you write two write locks, only one write lock will be given the access first, because as I mentioned, multiple read threads can execute parallelly, but multiple write threads cannot execute, because whenever you're saying write operation, only one write thread will work. After that, so whenever one write thread is working, all the read threads will go onto a wait mode. At the same time, another write thread also will go onto a wait mode. Okay. Kishore, does that understood?
Yes, yes, sir.
Yeah. So this is the beauty of, so now what is the difference between a normal lock mechanism and read-write lock? So can I say my entity, whenever you do any operation or any project, whenever you write any code, can I say reading and writing are the two options that you can do, correct? Now you have, whenever you're acquiring the lock, you need to segregate what kind of a lock you're acquiring so that you can make the process faster. Now in this scenario, when one thread started reading, then write methods will go on to a wait mode. Multiple threads can read. Multiple threads can acquire the read lock at a time on a same object, so that multiple threads can work parallelly, so that the output will be fast and accurate. But in the normal lock mechanism, whether it doesn't matter whether it's a read operation or write operation, only one thread can execute one lock, like synchronized block or locked method at a time on a same object. Other threads cannot execute any other method. So that is the advantage of having a reentrant read-write lock. Any questions? Does it make sense? Whatever the earlier program also will work, but in the earlier program, while I was doing the debugging, I have made continuous some wrong. Like when I say wrong in the sense, I have executed in a different way. So that's the problem. The same example only. Any questions? Should I repeat anything? Okay. So I have no questions. So now next look at, so this is about a lock mechanism, read lock, write lock, lock, unlock. Now, what is the drawback of a lock interface? So it is now we can achieve the lock in one method and release another method, a fair lock, unfair lock, read lock, write lock. All these are present in a lock mechanism. In the synchronized block, whenever you're working with a synchronized keyword, you don't specify reading operation or writing operation. But in the lock interface, it doesn't matter whether it's a different classic, but internally it is having a lock interface only, right? So in the read-write lock, one more advantage is you can mention write lock and read lock. Okay. Now, but whenever I'm using a lock interface, what is the disadvantage? Or whenever you are using a synchronized keyword, do you mention at which line of code it has to unlock? So
No.
I repeat my question. Whenever I use a synchronized method or synchronized keyword, when the lock will be released?
Once the method execution is completed.
Execution is completed.
If it is a synchronized block?
The synchronized block has to be completed.
That means the end of the synchronized block curly bracket, correct?
Yes.
So synchronized block, whenever you're writing, you will write synchronized block right like this. And you will put a open bracket, closed bracket. Can I say, if it is a synchronized block, after completion of line number 14, here, that means after completion of a end curly brace of synchronized block, the lock will be released, correct?
Yes.
Now, if it is a synchronized method, after completion of a method, the lock will be released. Am I right?
Yes.
But in the locking, whenever you are using a locking mechanism, when the lock will be released?
we are calling a unlock method.
So that means after the unlock method is called, then lock will be released. But whenever I'm writing the code as a developer, I will write a lock. Can I say that I can forget to write the unlock method?
Yes.
Is it happens? Yes. Now, so now, or sometimes what I will do if I do like this, now, can I say if there is some issue or some exception is thrown here, can I say my lock will be never unlocked?
Yes.
So so that means there are two things. When there is an exception, you need to unlock. When there is no exception also, you need to unlock. That means as a developer, you need to be cautious while doing the lock and unlock, correct? Now, if the unlock is missed, then the lock will be there forever. And then like all other threads will be waiting, correct? Because you are not doing the unlock. So when the disadvantage of lock mechanism is locking or unlock is in the developer hands. So since the flexibility is given to the developer or the user, then there may be a possibility that they might forget to write the unlock. So whenever they forget to write the unlock, or so the best way to use this unlock is in the finally block, correct? Finally block gets executed every time, right? Whether there is exception and whether there is no exception, can I say finally block will be executed?
Yes.
So that is the reason you might most frequently you will see finally block, the unlock will be written in the finally block. Okay. Now that is a good practice. If you write the finally block without like unlock without finally block, what happens is in this scenario, I don't get any exception. It's just a addition operation. But if there is a business scenario, you might get some exception. And finally block is the one which gets executed even though there is exception and even though there is no exception, right? So the best way to use is writing the unlock method in the finally block. And the disadvantage of a lock mechanism is using the lock mechanism, really establishing the lock and releasing the lock is in the developer hands, and the developer might forget to write the unlock. Now, can I say in using the lock mechanism, can I say multiple synchronized blocks in a single method? Can I write multiple synchronized blocks in a single method?
Yes.
Yes, we can write.
Yes.
Similarly, can I acquire multiple locks in a single method? Yes. So the thing you need to, as a developer, you need to remember the number of locks should be equal to the number of unlocks, correct?
Yes.
Yeah. If that is not matching, can I say that some of the threads will go on waiting mode forever?
Yes.
So that is a problem with the lock interface. So whenever we are using a lock interface, there may be a possibility that developer might forget to write the unlock method, or he can write an unlock method in somewhere. If there is an exception, it may not be executed. So the best way to write the unlock method in the finally block. And number of locks should be equal to the number of unlocks. Because in a method, I can write a synchronized block. So in a method, I want to, first I will execute some code that should not be synchronized. So I don't use this lock. Wherever the synchronized behavior I want to achieve, there I have to use a lock method. So this is about a lock. Now let me tell you, there is one important keyword called volatile. Does anyone know what is a volatile? This is related to the memory. So I cannot show you the program. I can explain what is a volatile, why the volatile has been introduced. Does anyone know what is a volatile keyword?
Yes, Karthik.
Yeah. Tell me what is a volatile.
Yeah, when multiple threads are working, say suppose if you declare one variable and if you try to increment, I mean, basically when you do composite operations on the variable, that will not be known to the other thread, so that it will try to increment, but still the result will be one thread incrementation only.
Yeah.
Same value shared to multiple threads.
Yeah. So here the basic thing is, what is a thread? Thread is an independent path of execution, correct? Now, independent path means, can one thread see what is happening in another thread? When it is independent, see, if as an independent house, can we know what is happening in other independent house? No, right?
No.
Simple as that, right? So at the same time, whenever as a thread, I have shown you that independent path of execution. Whenever there is an independent path of execution, can see here, what am I doing? Int I equal to, let me keep I equal to 5. So this is a I equal to variable. Now T1 and T2 started executing. What is the I value that both will see at the starting of the program? 5 only, correct? T1 also
Yeah,
will see
5
the
only.
value as 5, T2 also 5, correct? Now, so when T1 is performing 5 plus 10, what is the value? 15, correct? So can this be seen by, so I value is updated by T1 thread. Ideally, what do you think when T2 thread is performing I plus 20, can I say it should be like 15 plus 20 you expect, correct?
Yes.
Yes.
But what happens in the real life, I mean like internally is, so in order to happen this, can I say that T2 thread should know what is happening in the T1, correct? Because I value is updated in the T1. So as an independent path of execution, can one thread see what is happening in another thread? No, right?
No.
Because these are the independent. So when I say independent means that is what you do not have a relation to each other. So when T2 see, the problem here is each thread cannot see what is happening in another thread. So now the problem here is, so you are modifying the value, I value in the 15 here. So now here updated value should be present. If not, what happens? Here also it will see 5 plus 20. Here the I value is 25, here the I value is 15. Now what should be given to the user, correct? Now, so if this is a scenario, these kind of variables, now see this problem will come, like if you make them, now you will say, sir, I will make this, wherever I am doing this operation, I will make the methods as synchronized. Whenever you are synchronized, there is no issue. But I'm saying there may be a possibility of non-synchronized code also. So one thread cannot see, whenever you're doing a synchronized, what happens? At a time, only one thread will execute. But what is the scenario I have taken? I'm saying taking a scenario of multiple threads are executing at a time. Now, whenever you are doing this operation, one thread cannot see what is happening in another thread. So that means whenever the variable is value, it is holding the value, this value 5 plus 10, 15, where this I value will be stored. So for each thread, there is a memory called thread cache. Okay, so for this also thread cache will be there. Thread cache. So this, whenever I'm using a normal variable, whatever the modifications happen to that variable in the thread, that will be stored in a memory called thread cache. So whenever it is stored in the thread cache, now other thread cannot see, T2 cannot see the T1 thread cache. T1 cannot see the T2 thread cache. That is a problem. Now, if for example, I don't want to do this, I want to make this variable to be visible for all the threads. Then what I will do is, I will make this variable as a volatile. Volatile is a keyword in Java and it can be written to a global variable, not for local. It can be written for only variables. You cannot write a volatile keyword for a method. Volatile, I have to write a keyword in front of the data type. I can write volatile. Whenever I write the volatile, what happens? What is a variable? Volatile variable I. Any change happen to the I in any thread, immediately, so it will be present in the thread cache. Immediately it will be pushed to the main memory. When I say main memory, it can, where all the threads have the access. Okay. Now, or you can call it as a heap memory or wherever it is. Okay. Now, so here what is happening, whenever you are doing any operation on a variable which is a volatile variable in a thread, immediately that whatever the data that has happened, right, that will be available in the main memory. Okay. Now what other thread will do? These all the threads will have access to the main memory. So the other thread will take the value from the main memory and it will do the operation. Now when T1 is performing 5 plus 10, 15, now that 15 can be reflected here. Okay, and then on top of that, they can use 20, 15 plus 20. So the updated value will be there. And this 35 will be here. And any other thread is accessing this I, then it will see the value as a 35. That means whenever, so the use of a volatile variable is, using the volatile variable. So the modification for a variable that happened in one thread can be seen by other threads. Why? How it can happen? So because whatever the data that is happening, the thread cache immediately will be pushed to the main memory. So where other thread can see the value and perform the action accordingly. Now there will be one more question. What is the difference between volatile and transient? Have you guys seen this? Heard any of this time? Yeah. So volatile is this in multi-threading. Transient is nothing but whenever you're doing the synchronization. You don't, so synchronization is nothing but splitting the object into a series of bytes and sending over a network. So when I say employee, if I do employee object, what is the confidential data? User ID and password, correct?
Sir, is it serialization or synchronization, sir? You're
serialization. Serialization.
Yeah.
So
Okay.
I have taken this question. So this transient is that's not related to the threads at all. Okay. But I am telling you this question because this is the most frequently asked question. What's the difference between volatile and transient? So volatile can come in the threads concept. Okay. But transient does not related to a thread, but still they can ask. So that's the reason I'm explaining. So whenever we are using a serialization is nothing but splitting the object into a series of bytes and sending over a network. So for example, employee, there is a class called employee. So for that employee, I have a E1 object, E2 object, E3 object. In that E1 object, E2 object, E3 object, I will have a user ID password, user ID password, user ID password. Whenever I do the password serialization, after deserialization, they can know my password, correct? Do you guys agree?
Yes, yes.
Yes.
Yeah. But knowing the password is a right approach? No, you cannot share password, right? Now, that means whenever you are doing the serialization, you don't want to serialize for password, correct? I want to serialize only for like a name or salary or employee ID, etc. But I don't want to do the serialization for password, correct? Right? So whenever you do not want to do anything, any variable serialization, then before that variable, you add a keyword called transient. Transient also is a keyword that is added to the variables. If you add a transient keyword to that variable, then that corresponding variable will not be serialized. Hope you understand. Whenever we add a transient keyword to a variable, serialization will be stopped. Whenever you add a volatile to a variable, then whatever the change happened in one that variable in one thread, immediately that will be pushed to the main memory so that it will be available for other threads.
So we can use static also, right? Instead of volatile.
No, static keyword, it's a, okay, static keyword belongs to a class, right? But if this variable is not a static variable, then see here, did I talk about static? No, right? Volatile will be used for like, see, you are telling that if I have to make it as a static. Now, whenever I make it as a static, can I have an object specific value? For example, in the HDFC bank, what is a balance variable? If I take balance variable as a static and so Karthik account, I have initialized to 10,000. Any other object, if I change it, can I say it will be reflected here? Hope you understand.
Yeah, got it.
Static variable will acquire the memory only once, and through any object, if you perform, that modification will be reflected in all other objects, correct?
Correct.
Yeah, but so if there are some variables like a balance or salary, these are nothing but a object specific, correct? Now, if I have to have a object specific values, I have to go for an instance variable. Whenever I have to have an instance variable, then there may be a problem of this one, correct? So that's the reason you have to use a volatile.
Fine. Yeah, thank you. Yeah, for different objects also, it will have the same static value.
Yeah. So that is what the static reads. Static does not belong to an object, right? Now, what you can do in order to see that, you create a class called employee. Okay, I think Abdul, right? Sorry if I pronounce your name wrongly. Yeah. Employee. So let's make static salary. Okay. Now initialize it to 10,000. Okay. Now create one object, employee equal to new employee, e dot salary. Now create employee E1 equal to new employee, e dot salary equal to 2000. You change it. Okay. After that, sys out e dot salary and E1 dot salary. So what is the output? Can I say both the variables will show display 2000, correct?
Correct. Got it.
But is it the right way? Because salary belongs to a person. That means you should not make it as a static, right? Yeah. So here I'm talking about an instance. Whenever there is an instance, then it is an object specific value. But multiple threads, like the one thread cannot see other thread, what is happening. So if I make it as a volatile, it will be updated immediately.
So if there is a milliseconds delay, then it will be also a problem, right?
I did not understand.
Yeah,
You're saying sleep method here for some time?
yeah, sleep method or few milliseconds T1 is not.
Yeah,
in the
whatever
delay.
it is, even if it is a delay also, volatile, whenever there is an operation happened, immediately the volatile will push the data to the main memory.
But T1 already get the value, and T2, I mean T1 not updated it, but T2 also get the value. But
So
updated.
here, for example, before updating, you are going on to a sleep, or after updating.
Yeah.
See, for example, T1, in this T1, I equal to I plus 10. Am I performing? After performing, you are saying that sleep is happening, correct? Am I right? Or before performing?
No, before performing actually.
Okay, before performing, if this thread is sleeping, so at the time, assume that this thread is executing, correct? So it doesn't matter, any thread. So this I variable I'm using across the threads. Any thread which performs the operation, immediately that will be pushed to the main cache. So this thread is sleeping. Now this thread is doing the operation. I equal to I plus 20. So 5 plus 25, immediately that 25 will be pushed. And after sleep, this thread will come back to the execution, right? So then what is the I value? The I value is 25, it is no longer 5. So I'm not saying that T1 thread is only will be given. So whenever any thread is performing any operation on a volatile variable, immediately it will be available for the other thread, the updated value, if you keep it as a volatile. Understood?
Yeah.
So now let's in tomorrow class, I'll be talking. So guys, I have shared, sorry, I missed it. I have shared complete notes in the website as well as in the WhatsApp group. So can someone confirm if you are able to see that?
Yes, Karthik.
Yeah. So I request you to please go through the notes from today. So in this week, we'll be able to complete the course. So there will be a interview questions and answer session. So I request you to please go through from starting. Like, see, it's been almost 13th day, right? We have completed last Saturday also, and before that Saturday also, right? So we learned a lot. I request you to please go through a lot from starting. I've provided the notes in the form of a question and answers. So not only this, we will see some other questions also. But if you prepare, and whenever we are discussing about interview questions, I'll be asking the questions and you guys have to answer it. And then if possible, we will write the answers in the document, and that document will be shared with you all. So start preparing from today. Okay. Now in the upcoming class, so we have some more things to be studied. So we have seen synchronization versus lock, correct? I'm keeping it as star. Now someone asked me this course content. I will be sharing. I did not share it because I have written this arrow marks and all, right? I will remove this arrow marks and I will share this document also. So we are yet to discuss yield and weight method. And we have completed just now volatile, deadlock is pending, atomicity is pending, lock and synchronization is completed, reentrant lock is completed, rate lock is completed. So we have countdown latch, semaphore, cyclic barrier, thread local, yield and static method, yield and join method. Okay, I will explain all of those, and then I will also explain Java in the executor framework. We have a submit method, execute method, we have seen. But in the Java 8, there is one more method introduced called as invoke all. We will also see that. And I will also explain what is a producer consumer problem, because internally the producer consumer problem, we will be using blocking queue. This blocking queue is used in the, like inside the thread pool, internally I've shown, right? Blocking queue will be used. Whenever I explain this one, you will understand that. So once I remove this arrow marks, I will share you this, this doc, like course of content as well. Okay. So any questions?
Are we going to cover optimistic logging and pessimistic logging?
Optimistic. I can give you the overview. Yes, I can give you the overview. Yeah, if you want.
Okay.
Yeah.
Thank you.
It's all part of this, but I can give you. Yeah. So yeah, Sharma, do you have any question? Okay. So if no question, that's all for today, guys. Please start preparing from today, and we'll discuss. Like soon we are going to have the interview question session. You can be able to answer, right? Yeah. And I have shared, except today's code, I have shared the whatever the code that we have done so far. I have till Saturday, I have shared that code also. The code should also be available for you. Can someone confirm, please? Is the code available?
Yes.
Yeah, thank you.
Yes, sir.
So yeah, please go through the code, and the notes also have provided, and practice. That's all for today. So if no questions, we can wind the call. Yeah. Thank you all. Thanks for joining. Have a nice day.
Thank you, sir.